All right, guys, here we are today. Welcome to math. We're learning about substitution method, and this is like the sexy method of math. This is some good stuff. So solving linear systems by substitution. So our central question is, how can you solve a system of linear equations by using substitution? So let's go ahead and jump into it. We have some vocab. So if you remember last time we had that if it was a infinite solutions, then that means that they are the line, every point is a solution, right? That's literally what it means. Infinite solution means that every possible point is going to be a solution. Now, when we're solving using the substitution method, what this looks like is that we'll get A is equal to A, where A is any number, okay? So for example, 2 equals 2. So if you end up that 2 is equal to 2, then guess what? It's going to be infinite solutions. If it's no solution, then that means that there's no solution to the graph, this system. Okay. And again, what that's going to look like is, you see how for infinite was A equals A, where A is any number. In this case, A would equal B, where A and B are not the same. So for example, if you end up with 2 is equal to 3, then that's not a true statement. 2 is not 3 in real life, so that's going to be no solution. And one solution means, well, there's only one solution. And in this case, we actually typically, when we solve equations, typically we see them having one solution, and that's where it's going to look like x equals a number and y equals a number, okay? Or a point, so xy. So this is where you get 1 point for the solution. All right, well, let's jump into an example. So I saved this wonderful graphic organizer for you to kind of help you, guide you on this quest to using substitution. So what we're going to do is we're going to look at the equation. So we're given 3x minus 2y equals 9 and y equals 2x minus 7. So the first question is there a variable isolated? So what I mean when a variable is isolated, is there a letter that is by itself? And if I look at this equation, y is by itself. So I'm going to go ahead and mark up the y so you can see that y is by itself. So since y is by itself, then yes, there is a variable isolate. So I'm just going to go this way. All right, I'm going to go to the left. So now what we're going to do is we're going to get into the substitution. So since I know y is alone and isolate, oops, that's why I'm not actually marking it up. So I know y is alone, and y is equal to 2x minus 7. What I'm going to do is I'm going to take that, and I'm going to substitute it into the other equation for y. And what I mean by that is I'm going to have, if you look at the other equation, the one where there wasn't a isolated, was 3x minus 2. And what I'm going to do is replace y with 2x minus 7. And that's equal to 9. And again, I'm just going to kind of put this in a different color. We'll just do y equals 2x minus 7. So that's where I took the y. Remember, y is equal to 2x minus 7. So all I did is over here is where there was a y in the first equation, I replaced it with 2x minus 7. So take a second to really make sure you have that, because this is kind of where it gets confusing. So now that I have the same variable, I have 3x minus 2 times 2x minus 7 equals 9. I'm going to solve for x. And so I'm just going to do my math. Well, first thing I need to do is the distributive property. We will not use green because I was told you guys hate that. So when I use the distributive property, I get 3x minus 4x plus, because it's negative 2 times negative 7, so plus 14 equals 9. I'm going to combine my like terms and start solving. So 3x minus 4x is negative x. And then when I subtract 14 by both sides, I get negative 14, sorry, 9 minus 14, which is negative 5. And the last step is to divide by -1. And when I do that, I end up with x is equal to 5. Okay. And since I have x is equal to 5, I'm going to go ahead and I'm going to circle that because it's not my answer, but it's part of my answer. So there we go. I got x equal to 5. All right, so now that I have x equals 5, I need to find y, because remember, a solution to a system, if you think about what we did when we were graphing, the solution was where they crossed, right? Well, I know so far that I'm going to end up with some sort of solution because I got x equal to 5. So I need to find out what y is equal to when x equals 5, so I can find out the point that they cross at. So what I'm going to do now is I'm going to take the 5, the value I got from step 2, and plug it in up here for y equals 2x minus 7, and I'm going to solve for y. So let's do that. Remember, again, looking at that equation, y equals 2x minus 7, we got from above where we had y by itself. All I'm doing now is replacing x with 5. So y equals 2 times 5 minus 7. And then I just do my math. This is a two-step equation. 2 times 5 is 10, so y equals 10 minus 7. And as you can probably tell, y is going to equal 3. All right, now let's get this all looking pretty. We'll just leave it like that. All right, so now I got y is equal to 3. And again, circling that. So based on this, I know that my solution should be the point 5, 3. So I know my answer should be 5, 3. But in order for me to check it, I need it to work in both equations. So what I'm going to do is I'm going to check to make sure it works in y equals 2x minus 7, and make sure that it also works in 3x minus 2y equals 9. So let's check. We'll check y equals 2x minus 7 just because it's already set up for us in a really nice way. So y equals 2x minus 7. And again, what I'm doing is I'm checking to see if when x equals 5 and y equals 3, that this is still a statement. So does 3 equal 2 times 5 minus 7? Well, yeah, 2 times 5 is 10. 10 minus 7 is 3, so 3 equals 3. So yes, it does work here. So then let's check the other side. I need to make sure it works for the other variable. So now I need to make, well, the other equation. So let's check the other equation. The other equation is 3x minus 2y equals 9. All right, and then again, I need to check if when x equals 5 and y equals 3, this is true. Well, does 3 times 5 minus 2 times 3 equal 9? That's really what I'm trying to get to the bottom of. 3 times 5 is 15. 15 minus 2 times 3 is 6. And again, I want to see if that equals 9. Well, 15 minus 6 is 9, and 9 equals 9. So I did this right. So because this point works for both equations, then the point 5, 3 is my solution. So I'm just going to take my box 5, 3, because we got an answer. All right. So that's the first example. We're going to do one more example, and this one we're going to do because there is not, if you look, preview this, we have x plus y equals 4 and negative x minus y equals 6. So chances are, since the last example we did, the variable was isolated, this one, the variable is not going to be isolated. And even if you look, there's no variable that's by itself, like y equals or x equals. All of them are attached with addition and subtraction. So is there a variable isolated? No, there's no variable isolated. So this time I'm going to go to the other direction. Oops. Don't want to highlight everything. Man, it really does not want me to do that, does it? There we go. All right, so no. So we have to isolate the variable that's easiest. So in this case, it's going to be easier to isolate either x or y in the x plus y equals 4. The reason why I say that is because in order to get x or y by itself, I just need to subtract one of them. So I'm going to, for this case, I'm just going to subtract y over, and I'm going to solve for x, just to kind of mix it up a little bit. So here, I have x plus y equals 4. I rearrange the equation to solve for x, then it would be x equals 4 minus y. Because remember, to get the y to the right-hand side, I have to change the sign and subtract it. So if I subtract it over, I get x equals 4 minus y. Okay, so now that I have it by itself, I'm going to put that into the other equation, and I'm going to solve for y. So let's do that. So remember, the other equation is negative x minus y equals 6. Probably have the right letters there. Okay, so then what I'm going to do now is I'm going to take it and I'm going to put in 4 minus y for x. So I'm going to have negative 4 minus y equals 6. Okay, so now that I have it set up, I'm going to go ahead and do the distributive property. When I'm multiplying a negative in, it's like multiplying negative 1. So I get negative 4. Negative 1 times negative 1 is positive 1. So plus y minus y equals 6. And again, I just multiply the negative in. And now I'm going to combine my like terms. Well, notice that when I have this y minus y, those are going to cancel. So when that happens, I get negative 4 equals 6. So right away, negative 4 equals 6. That is actually not a solution, right? Negative 4 and 6 are not the same number. So if I go back up here, since they're not the same number, this means that this system has no solution. So right here in the answer section, I'm just going to type, no solution, because again, negative 4 and 6 are not the same answer number. So this one is going to have no solution. And so that's what's kind of nice is like, even though you think no solution and infinite solutions would create these really complex problems, they're actually the easier ones to solve, because as soon as you get here and you have either negative 4 equals negative 4 or negative 4 equals 6, you're done. You either know that it's no solution or infinite solutions. However, conversely to that, if you end up with an actual number, then you can bet that it's actually going to, you're going to have one solution. And that's how we do it. So now try to think, how can you find the solution of a linear system by substitution? Hopefully you have enough information now to do that.